Hello, and welcome to the wonderful world of server-side tagging in Google Tag Manager. In this video, we'll take a look at how to build your own client custom template in GTM. The reason we want to walk through these steps is because the client is such a fundamental part of how server-side tagging works. The client is responsible for digesting those incoming HTTP requests, like the Google Analytics request, parsing it into an event schema, and then passing that event to a virtual container that fires your tags and triggers and variables within the server container. So in this video, we'll build our own Universal Analytics client, which is similar to the built-in Universal Analytics client with a little catch. It will also rewrite the GA cookie and return it with the HTTP response back to the web browser or the device that sent the hit. And the reason we want to do this is because by using HTTP cookies like this, our site will be a bit more resilient against measures like the intelligent tracking prevention in the Safari browser. And you'll be able to validate and manage your cookies a bit better. I hope you enjoy the video and make sure to read the accompanying articles listed in the notes of this video. We are here in the server container I have created for my own website. And in this video, we're going to be working on a Universal Analytics client whose purpose is to intercept the incoming measurement protocol requests, process them, send them over to Google Analytics servers, and respond with a set cookie header. And the reason we're using the set cookie header is because we want to write the Google Analytics cookie using the HTTP headers, and thus avoid issues with, for example, Safari's intelligent tracking prevention, cutting the expiration of the first-party cookie. So this is what we'll build. I'll start from scratch, just so that you can see the process. And we're going to be following the blog article, Build a Custom Universal Analytics Client, but we're also going to add some extra stuff to this client that's not present in the blog post itself. We have our main website container here. We're also in preview and debug mode for the server container here. And we're also in preview mode. We're going to be in preview mode soon for the main website. So this is the starting setup. And to start building a client, we're going to go to templates, and then we will create a new client template. And you'll need to, this is exactly how custom templates work for the web as well. You'll need to give some name for this. So let's call it Universal Analytics Improved. You could add a description here. You could even add an image. And if you want to publish this custom template in the community gallery, you would check this box. Under fields, we don't actually need anything for this particular client. We could add some configuration options, such as if the user wants to change the cookie name, we could turn that into an input field. Or if they want to not write the cookie at all, we could turn that into a checkbox. If you wanted to process the GA EXP cookie as well for optimize, you could add it as an option here. But just to keep things straightforward, we're not going to add any customization options here. So this template will always work in a single specific way. When you look at the code tab, you can see that there's a pre-populated code tab here. And the only API that's being in use or that's being called is the claim request API. So the claim request API is basically a way for this particular client to tell all the other clients running in the server container that I'm taking this request. No other client must touch this request. And this is actually a very important API to use, because if you didn't use this, what could happen is multiple Universal Analytics clients could process the same request and just send the data over and over again to GA. So generally we want to build templates so that there's one client for one type of incoming request. But I could see a potential way to build clients in the future where you deliberately allow multiple clients each to process a request. But this is just something that I've been thinking about and haven't formulated it into a proper setup yet. So what this client must basically do, it has to check if the incoming request is a measurement protocol request. If it is, it needs to claim the request. Next, it needs to extract all the events out of that measurement protocol request and then run a container with those events. So events in this scenario mean those individual calls to Google Analytics, because you could theoretically batch them into a single measurement protocol hit. But in this case, we're going to basically just assume that there's just one event per measurement protocol hit. But this template would theoretically work for batched hits as well. Once the container has been run with the event, this template will take the GA cookie from the initial request, the incoming request, rewrite it as an HTTP header, and then respond back to the device. So that's the core of what we want to do in this client. So let's start setting things up. We're going to need a bunch of APIs, but I'm going to get to them once I run the code forward. So the first thing we need to do is we need to check if this request is a measurement protocol request, and there's actually an API for that. So the API is called is request MPV1. MPV1 means measurement protocol version 1, and there is actually a measurement protocol version 2. That's for App plus Web, but we don't need that in this particular case. So we're just going to use this single API. So this is how we include that API in this template. So the first thing we do is we check if the incoming request is a measurement protocol version 1. That's how you run the API. You just call it like a regular function. And if it is, we need to claim the request, which uses an API called claim request. Like so. So again, if the request is a measurement protocol request, this client will claim it, and it won't let any other client process the request after this. So we're hogging this request. So the next thing we have to do is we have to extract all the events out of this measurement protocol request. Now we could kind of use APIs like we could parse all the query parameters of the request, and we could manually convert those into a unified event schema. And that's what you'd have to do for non-Google templates. For example, if you wanted to use a Facebook template, or if you wanted to build your own template, you would extract the request body or the query parameters from the HTTP request, and you would kind of turn those into the unified event schema. So if you're wondering what these query parameters are, here's an example of an incoming measurement protocol request. This is just a very regular measurement protocol request where all the parameters are in the query string. So you have version here, you have hit type is page view, and so on. So you would have to manually parse these query parameters and then convert them into the kind of event data model that Universal Analytics expects. Well, luckily, this is a Google template, or you're communicating with a Google endpoint. So you don't have to manually do this stuff. There is actually an API for this called extract events from MPV1. And again, there is a similar API for MPV2. Like so. So first thing we do is we extract all the events from this request. Const events is extract events from MPV1. So now the events now holds an array where every member is an event data object corresponding to the parameters in the measurement protocol request. So what we next have to do is we need to loop through all the events in this array and run a container with each event. So running a container means we basically, it's similar to a data layer push. We create a trigger event that then tags in the server container can react to. So we need to run the container with each event, and after the last event has fired or has been completed, then we return the response. If we return the response before the last event has been run with the container, it's possible that the response will be incomplete, or you're missing important information because you kind of aborted the request response flow before it was completed. So first thing we need to know is we need to know how many events there are. So let's do a maximum variable here where we want to know what the index of the last event is. So if there's just one event, the max would be 0. If there's more than one, it would always be the length of the array -1. And we use -1 because we're going to be accessing the index number here. And we're going to be doing that with a simple for each loop. So events for each. So here we can see that we're going to be looping through every event, and every iteration gets the current event and then the index number of the event. And then what we have to do is we're going to have to call the run container API. So run container means that you do the kind of data layer push thing. So run container, require run container. So we're running the container with each event. Run container takes a couple of parameters, but we only need, the first one is event. So this has to be a fully formed event data object. And one particular thing that it needs is the event name parameter. Without the event name parameter, things are not going to be working, because this is the event name over here. Timing complete, page view. These are the event names. If you don't have an event name, the client will not work as intended. So the first parameter is the event. We're calling run container with the event object. And the second parameter is an onComplete. So when each iteration of the run container has finished, it calls this callback. So we're just going to use an anonymous function there. And the callback will check that if this was the last iteration, then we kind of run the response. So we check that if index, so index is from here, this is the current iteration index number, is max. So if we're currently iterating through the last item in the events array, then we run a bunch of stuff here. So this is the base logic. Let's just quickly go through it again. We check if the request is measurement protocol. If it is, we claim it and prevent other clients from working. Then we extract all the events from the measurement protocol request into an array of event objects. We loop through this array, going through every event in the array. We run a container with each of the events. And then we check that once the last event has signaled completion, so all the tags for that event have fired, then we basically return response. So return response means that an HTTP response is returned back to the origin or the source of the request. So this client would theoretically already work. It would run the container with everything from the measurement protocol request, but we want to do so much more. So one of the things we need to do is that if you run it like this, Google Analytics would receive a hit from the server container, and it would interpret the IP address and the user agent as those of the server container itself, rather than the user who sent that request from the browser. Now this is great for privacy because obviously a user agent and IP address are fingerprintable surfaces. So if you wanted to obfuscate all this information from the request, just leave it like it is right now. Every single user would appear to come from the same IP address range and the same user agent, which would be, I think, a great win for privacy. But let's consider the fact that you've asked for consent and the user has given it, and you're allowed to kind of pass their details to the outgoing request to Google Analytics. So we need a way to extract the IP address and the user agent from the incoming HTTP request and attach those to the outgoing request to Google Analytics. And there are APIs we can actually use for this. So to get the IP address, we're going to use something called get remote address. So this does like a best effort extraction of the IP address. It's not an exact science. The IP address isn't always in a reliable place in the headers, and it's not always a reliable thing to use in the first place. But we're going to do a best effort guess. And for the user agent, we're going to actually have to access a request header, a header in the HTTP request. So let's do get request header. So let's just take a look again here. Here's the incoming request. You can see that there's a header called user agent that we're going to be using. So we need to extract this header named user agent so that we can pass it on to the Google Analytics. The user agent string is basically a string that describes the operating system and the browser the user is using. It's not exact science either, but again, we're just trying to go for a best effort approach here. So we can do those checks up here with just after claim request. So let's do const user IP is get remote address. So this should now store the user IP address. And const user agent equals get request header user agent. It can be lowercase or however you want. It's not case sensitive. So then here, once we're iterating through every single event, we need to add the IP address and the user agent to that event. So the event model that the measurement protocol endpoint the event model that the Google Analytics tag in the server container uses, it has two fields specifically for this purpose. So there's a field called IP override and a field called user agent that we can override. And those get attached to the measurement protocol request to Google Analytics as the IP override and the user agent fields. So the first thing we need to check, if the event doesn't already contain the IP override field, because it's possible that the incoming HTTP request already had an IP override. If the event doesn't have IP override and we found a valid IP address, so with this is a valid value, then we override the IP address with the IP from the request. Same thing for the user agent. If the event doesn't already have a user agent field and there is a valid user agent string, we're going to be overriding the value with that of the incoming request. So this way we can mask the outgoing HTTP request to actually be in sync with that of the user who sent the initial request to the server container. Naturally, you might want to add there an anonymize IP check as well. So if the user has anonymized IP in the event, then you would kind of negate the last zero. You would actually, maybe at that point you could go do even better. So just not override the IP at all and use the server container IP address. Maybe that would actually be the coolest way to implement anonymized IP. We're not going to do that here. It's just a complication that I don't want to explore at this point. So now that we've added the IP override and the user agent to the event, the container is run with the event with now the updated IP and the user address, user agent. So the next thing we have to do is once the container has been run, we need to update the response with a couple of things, including the set cookie, header, and then something else that I'll explain in a bit. And just to get my OCD in place, we're going to go in alphabetical order here. Right. So we're going to have to do, we're going to have to first check if there is a cookie. So we're going to use the get cookie values API. This retrieves all the values for a given cookie name. We're also going to use a set cookie header to set the cookie in the HTTP response. So before the return response, once the return response has been called, it's too late to update any of the headers. So what we're going to do here is we're going to first check if the request, or we're going to get the GA cookie from the request. So const GA equals get cookie and then the cookie name. So this fetches all the cookies with the name GA_GA from the initial HTTP request. Then we're going to check if that cookie was found. And there's more than, there's more than one or more cookies there. And then we can set the cookie. So only if there is a GA cookie in the request can we actually rewrite it. You could add something here that if GA wasn't found, then you would build your own client ID, for example, and set that in the cookie. Though, of course, you would first have to pass that client ID to the event object as well, so the outgoing request would be updated accordingly. But let's just assume that there's always a GA cookie available. So the first value for set cookie is the cookie name. Then we get the cookie value, so we take the GA cookie variable, but because it's always an array, we just get the first value from the array. So if there was more than one _GA cookie, such as those written on different subdomains, this would just always get the first one. So you'll need to do some due diligence to make sure that you only You're only sending one _GA cookie if you want this to be absolutely accurate. And then we pass a configuration object. So here we need to pass some cookie configuration. So we'll set the domain to auto. Auto means that it tries to write it on the highest possible privately controlled domain name available in the request on the server container. So if the server container is running on collector.cmojava.com, it would try to write it on cmojava.com. If the server container is running on the Google Cloud without a custom domain, it will try to write it on appspot.com and then your project ID or your project domain for appspot.com. So that's why it's kind of important to make sure that the server container runs on your own custom domain so that you can kind of treat it as a first-party cookie as well, anything it tries to write. We set a max age of 2 years. Max age takes a value in seconds. So we have 1 minute, 1 hour, 24 hours, 365 days, 2 years. Then we set the path. So unless you have very good reason not to, always set it on the root. We're going to say secure true, so we only allow the cookie to be passed if the request happens over HTTPS, a very good precaution to take today. And then we're just going to set same site to lax, which means that it's only available in first-party context. If this cookie needs to be accessed in an embedded iframe with cross-domain tracking, for example, you'll want to set it to same site none. But otherwise, it's good to just default to lax. So once you've done this, the cookie is now set in the headers and the response is sent. One last thing you need to do is if you would just return the response like this, the measurement protocol endpoint in your server container would respond with the default headers, like it would be a text response without any cache busting going on. So there's actually an API here that turns this measurement protocol request into an image pixel request. So similar to how Google Analytics' own endpoint works. Using an image pixel has some benefits. For example, browsers won't cache it as aggressively, and not caching the request is very important, because if the request were cached, then all the query parameters and everything would be always loaded from the browser cache rather than the actual things that the user sent. So there's an API for this called setPixelResponse. This automatically sets all the necessary fields to make the request resemble an image pixel. So now we are pretty much done with the first part of this tutorial. So let's just go over it quickly again. We're checking if it's a measurement protocol request, then claim it. Extract the user's IP address and user agent from the incoming request. Extract all the events from the measurement protocol request. Loop through all the events. And for every event, update the IP override and user agent fields with the actual IP and user agent from the incoming request, so the user's or the browser's actual IP and user agent. Then run a container with each event, and as each event completes, check if the event was the last one in the batch. If it was the last one, the next thing you do is you check if there was an _GA cookie in the request. If there was, you rewrite it with the same value, just setting its max age to 2 years. Write it on the top most privately controlled domain name of the server container in the root path with the secure flag and same site lax. You turn it into a pixel, so you make the response appear as if the user requested a 1 times 1 pixel image, and then you return the HTTP response back to the browser or the source of the request. You're going to need to add some permissions as well. But before we go there, let's do the second part of what I wanted to show you. Because one additional thing you can actually do with the server container is you can proxy the analytics.js library itself. So instead of loading analytics.js from Google Analytics, you load it from the server container. And this is helpful in cases where browsers are blocking the Universal Analytics library itself. But again, I'm not saying that it's cool to circumvent content blockers, But there might be reasons for that you want to also load third-party vendor libraries from your own endpoint, such as reducing client load, reducing reliance on third-party domains, making it easier to manage a content security policy, making it easier to set your own cache headers, for example. But anyway, what we're going to do is we're going to be allowing another type of request that this client can claim. So this request would claim all measurement protocol requests. That means requests that have the collect path in them. So they look like something like this, collector.simoahava.com/collect. This would be a measurement protocol request, and this is what would be claimed. But there's another type of request we want to enable, so analytics.js. If this is requested, then we want to return the universal analytics library to the original source. So what we'll be using is a get request path API, like this, and we're going to do if get request path equals analytics.js, like this, and then again we're going to claim it. So these are now the two scenarios where the request is claimed. Either the request path is analytics.js or the request is a measurement protocol version 1 request. And now there's a cool API for Google scripts like analytics.js and gtag.js. We're still waiting for support for GTM itself, so being able to proxy the Google Tag Manager container itself. That will be very cool when that's possible, but it's not supported yet. But the API we need is called get Google script. It's capital analytics. Oops, sorry, I'm a bit ahead of myself, so let's do require get Google script first. So to retrieve the analytics.js, get Google script creates an automatic get request for the analytics library in Google servers. So we do get Google script analytics, written like that, will fetch analytics.js. The second parameter is a callback that is called with the response. So we do just two parameters here. And one thing we want to do is the metadata contains all the headers of the response. So all the headers that Google servers return with when they return the analytics.js library. And we want to take all those headers and put them in the actual response this client creates, because we just want to make sure that whatever is loaded from Universal Analytics servers stays exactly as it would if the request originated from the browser and was sent directly to Google. So we're going to use an API called const set response header. So this sets individual headers in the response. So this is a very simple thing. We're going to loop through all the headers in the analytics script response, and then we're just going to set all those headers in the response as well. So set response header. So header is the header name, and metadata square brackets header is the content. So if there's a cache control header, for example, it would set it exactly the same way in the response. We're also going to need to set a content type header to make sure that the response is a JavaScript, interpreted as JavaScript. If you don't do this, then it's possible the browser doesn't actually execute anything when it gets the analytics.js library as a response. So content type, text, JavaScript. And then finally, we need to actually set the response body to the script itself. So for that, again, of course, there's an API. Set response body. Like so. So we set response body to script. So script is what was returned. This is the actual body of the analytics.js request. And then we run return response here. So now we're intercepting both universal analytics request for the analytics.js library and measurement protocol requests. So if either one is sent to our server-side template, we're going to be intercepting them. One last thing you need to do is that some browsers will not show what the response was. They'll be able to send a request to the server-side endpoint, but they won't process the response because of missing course headers, so cross-origin resource sharing headers. So we need to set those course headers as well. Luckily, this is quite easy. So the course header basically makes sure that this server container endpoint accepts requests and sends responses from domains that are not the same as the server container itself. So because we won't be sending any requests from the server container domain itself, we need to set those course headers for some particular browsers. So it would be before return response, we need to get the origin of the initial request. So origin means basically the protocol and the host name of the request. Origin. If there was an origin in the request, then we set a couple of headers. So set response header, access control, allow origin. And then we set response header, access control, allow credentials. So these two headers basically make sure that cross-origin requests aren't blocked and the responses aren't blocked by the browser sending the request. And we need to repeat that for our measurement protocol proxy as well. So now we're pretty much done. The last thing we need to do is set some permissions. So we need to allow access to any part of the response. We're setting headers, we're setting status codes, we're setting the body. So we need to set it to any. For cookie values that are read, let's do just _GA. You could do, same thing for GAXP if you wanted, or maybe even Facebook, whatever you want. So we want this to be allowed only to read the _GA cookie. With permissions, I recommend always being as strict as possible. It's just a good habit to fall into to make sure that templates are not too enabling and don't allow you to do all sorts of things. So you would always have some sort of governance in place. Let's allow the request to read any part. Let's allow the client to read any part of the request as well. Return response has nothing. Run container has nothing. And to set a cookie. For the cookie, we wanted to set the GA cookie. You could set an allowed domain name here, for example, simahava.com. But for the purposes of this example, no, actually, let's walk the talk. simahava.com, path, secure, and any type of cookie, session or non-session. Just make sure that this domain reflects what the request will actually be coming from. And then we can save the template. So now for the purposes of this demo, I already had the very same template over here. I'm in the wrong container, sorry. So we have this universal analytics with cookie response over here. So the next thing we need to do is we need to create a new client. And we're going to choose our custom template for client. Let's call it Universal Analytics Improved. So this is our client. And the next thing one thing we have to do is we have to set the priority of this client. So as you can see, there is another Universal Analytics client in this container. Well, I want to make sure that my Universal Analytics client is always run first. So the original client has a priority of 100 and the new client has a priority of 0, which means that the original client would always win and most likely would claim the request so that my new client wouldn't be able to do anything. So what I have to do is to make sure that it has a higher priority than the original one. So we're going to set this to 101 instead. So now my new client will be run first. Then we need a Universal Analytics tag, and we already have one over here. So you can find the Universal Analytics tag in the list of supported tags. You just take the pre-built one. If you want, you can override individual fields like the tracking ID or fields to set. We don't have to do any of that. And then we just need a trigger to run on this tag. And now we want this tag to fire whenever our client runs the container. So how this works is that you create a new trigger. Let's call it Universal Analytics Improved. There is just one trigger type for now. If you set it to all events, it would fire regardless of what event the run container API was called with. I might have Facebook there. I might have Hotjar there. I only want this to fire when the Universal Analytics Improved client fired it. So you need to choose client name from the list of variables. If you don't see it, you have to first enable it as a built-in variable. So in this overlay, you look for client name. You make sure that it's enabled. And then you can do Universal Analytics Improve. Just make sure you avoid any typos. I hope this becomes like something where you don't have to type anything, but you could just choose the client name from a drop-down list just to avoid those nasty typos. So here we have our Universal Analytics tag, and this is a pre-built tag. It expects the APIs for measurement protocol to have been used. So extract events from MPV1, for example. It digests the kind of universal event schema that those use. And then we can go to preview mode. So this is now preview mode for our server container. But before you can actually send anything to the server container, you need to make some modifications to your web tags as well. So the first thing you'll need is you'll actually need a tag that sends the data to your server-side container rather than Google Analytics. So an easy way to do this is to take your regular page view tag, for example. So this is just a regular Universal Analytics tag sending data to Google Analytics. Make a copy of it. Name it something like server-side or whatever. And then you scroll down all the way to its advanced configuration, where you'll see the transport URL field. It's a new field in the Universal Analytics tag. And when you type here the base URL of your server-side container, so for me it's sgtm.cmao.com, without the trailing slash, so just like this, just the origin. Now, anytime this tag fires, it will actually send its data to the server-side container, to this URL, instead of Google Analytics. And the other thing you'll need is you'll need to be able to load analytics.js from the server-side endpoint. So for that, let's just, for simplicity's sake, you could use a custom template, and you should. But just to show you how it works, let's use a custom HTML tag. So all you have to put here is script. src is sgtm cmao.com/analytics.js. So this will load the analytics.js library from your own server-side endpoint. Let's not add a trigger to it now, because what we're going to do, actually just one more thing you need to do. Make sure that it fires just once per page. You don't want it to fire all the time in case you'll be adding it to multiple tags. So once per page like this. So the reason we're not adding a trigger to it is because we're just going to set it to fire in sequence to our server-side tags. So down here in tag sequencing under advanced settings, we're going to go with fire tag before server-side page view fires, and we're choosing our analytics.js tag, like so. So now we have a server-side page view tag sending data to our server-side endpoint. It first loads analytics.js from our server-side endpoint. There's just one last thing you have to do before you can test the whole thing. If you were now to publish your container, it would work nicely. You would be collecting hits through your server-side container, and it would send them to Google Analytics, and everything would be fine. However, each time a regular Universal Analytics tag fires, or GAV2, so Atlas Web tag fires, it would rewrite the cookie, the GA cookie, as a JavaScript cookie, because that's how these libraries work. They rewrite the cookie as a JavaScript cookie each time the tag fires so that it refreshes the expiration. So we need to tell these tags to not refresh the cookie expiration, because that's what the set cookie header does in our custom server container tag. So to do that, you take your universal analytics tags, you scroll to fields to set, and you add a new field called cookie update equals false. When you set cookie update to false, it will write the cookie if it doesn't exist, but it will not refresh it after that. So that's fine. We want it to write the cookie in case you're doing things like cross-domain tracking and you want the linker to work in the browser. You have to do the same thing in your GAV2. So easiest is to just go to the Atlas Web config tag, Atlas Web config tag, and just add it to the cookie. It's written differently. It's cookie underscore update versus cookie camel case update, but it does the same thing. And now you're all done. So let's go to preview mode. Your server container is already in preview mode. Open the website running your tags, your web container, and then just to make things clear, let's open the network tab, and then we can just reload the page. So now you're going to looking for hits to your server container. So sgtm.cmojave.com. Here we can see there's a request for analytics.js. So here we have the analytics library sent from our server-side endpoint. We have our page view request sent to our cmojave.com endpoint. It's responding with a status code of 200, so it seems to work nicely. And most importantly, it has the set cookie header, which sets the cookie on my domain with a 2-year expiration, same site lax, and secure. So if we now check what cookies we have running in this container, you can see that there's a GA cookie, not that one, but this one, a GA cookie, 2-year expiration, secure, and same site lax. So seeing same site lax and secure here means that your cookie rewrite is working. If this were written by JavaScript, GA's own JavaScript, you wouldn't see the secure check mark and you wouldn't see same site here. So what we can do here is just reload and then check what debug mode shows us. So we see our requests claimed by the client, and they fire our universal analytics tag. So our universal analytics tag is now firing the data to Google Analytics. And the response, as I already mentioned, the response on each request has the set cookie header, setting it to my own domain. And just to show you the impact of the set cookie header, if we head over to Safari and load the site, you can see that the GA cookie now has a 2-year expiration. So if we didn't use our server container, the GA cookie would only have a 7-day expiration. So this is how you build a client template in a server container. And just remember to configure your other tags as well, because when you build that server-side proxy, if you're still running web tags, regular tags, you need to make sure that they don't overwrite the cookie itself. And remember to read the accompanying article, as well as my larger guide on server-side tagging. And that's it. Thank you for watching.